6th grade math students. We've made it. This is the last math lesson, new lesson of the year. We're at the last chapter, chapter 14, and the last lesson section, 14.4. Congratulations. You're not quite there yet, but you've worked really hard and we're so close. Don't give up now. I want to see excellent scores on this next math test, and I believe in you. You can do it. All right, enough pep talk. We are on page 264 in your math book. If you need to pause the video to go get your math book, please do that. These videos, as I'm sure you've noticed, since there have been many of them now, are not designed to be just watched, but rather followed along with in the math book. So we're on 14.4, last math lesson, new lesson of the year, on page 264. All right, as is standard for a lot of these lessons, our last one of the chapter is real world problems using mean, median, and mode. All right, let's look at the deciding whether to use mean, median, or mode on page 264. The table shows the sizes of inline skates and the number of pairs of skates sold in a month. So here we have a table. It's labeled number of pairs of inline skates sold. The different sizes are listed in numerical order, size 6, 7, 8, 9, 10. And then the number of pairs, or the frequency with which people order each pair or each size, is listed in the right-hand column. So we have 12 number of pairs of size 6, we have 15 pairs of 7, 18 pairs of 8, 9 pairs of 9, and 6 pairs of 10. All right, now let's kind of walk through the steps they give us. How many pairs of inline skates were sold? So they're asking us for the total, right? Think to yourself, how would we find the total of skates sold? The total of skates sold, words. The total number of pairs of skates sold. Well, hopefully you've thought to yourself, we would just look at the number of pairs for every size and add them all together, right? So we're just going to add 12 plus 15 plus 9 plus, I skipped a number, 12 plus 15 plus 18 plus 9 plus 6 equals 60. Sorry, I may be tripping on my words today. I'm a little excited that this is our last new math lesson. All right, B. What is the mean size of inline skates sold? Now we know from our previous chapter, or not chapter, previous lessons in this chapter, that mean is the total of the sizes of inline skates sold divided by the total number of pairs sold. So let's figure out how we're going to do that. We're going to do 12 times 6 plus 15 times 7 plus 18 times 8 plus 9 times 9 plus 6 times 10, and divide that all by the number of total pairs sold, 60. So it's going to end up being 462 divided by 60 for a mean size of 7.7. Now, let's walk through again why we would do that. Why are we multiplying the size times the number of pairs sold? Well, each size needs to factor in to the average size, right? But the number of pairs sold is going to kind of offset the impact of that size. Let me see if I can explain that a little better. It's almost like some of these numbers hold more weight because more of that size are sold. So that we don't want to just average 6, 7, 8, 9, 10 because those are our options. We want to make sure we're averaging all of the numbers together. So the 12 sixes, the 15 sevens, the 18 eights, the 9 nines, and the 10 sixes. So the size 10 sorry, I may have said it all backwards. It would be the 6/10s. There we go. The size 10 is not going to factor as much into our mean or our average because there were only 6 pairs. Whereas the size 8 is going to factor in a higher amount to our mean because there were 18 size 8s. So that's why we're multiplying it all out at the beginning. You see they did it all in one line. If that confuddles your brain a little bit, you can go ahead and just do the 6 times 12 and in one line over there, and then figure out 7 times 15, 8 times 18. Figure those all out separately, add them all up, and divide them by our total number of pairs sold, which we found earlier was 60. I got a little deeper in there with that explanation. Hopefully that made sense. Let's move on. I think things might get even easier from here. So after we did that division, we found that the mean size of shoes sold was 7.7. Now, I'm kind of jumping ahead a little bit here, but does a size 7.7 actually exist in shoe? The answer is no. So that while that data point is helpful, knowing the mean, we may have to do something to it later, or we may not have to, but a person in a real life running the supply chain may have to think a little more carefully about which measure of central tendency they use, because they can't order size shoes in size 7.7. All right, let's keep moving on. We're on part C, the top of 265. What is the modal size of inline skates sold? Now, they haven't used this word for you before, but modal is just the adjectival form of the word mode. So don't freak out when you see modal. You're like, I haven't done modal anything. No. They're just asking you, find the mode of the inline skates sold. The size of the inline skates that sold the most frequently mode, is size 8. So the modal size of inline skates sold was 8. We found that out from looking back at our chart. There was the greatest number of pairs, 18, sold in size 8. So size 8's our mode. Now they want us to find the median size of the inline skates. All right. We talked about this a little bit when we did the median lesson. And technically, yes, you can lay out all of these numbers and go, all right, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 8, 8, 8, 8, 8, 8, 8, 8, and lay out all of your numbers numerically, the number of pairs for each size, and then count from the outside to find your median. But listing 60 numbers out in a row isn't always the most practical. So let's read and see what they did. It says first you need to find the middle sizes. 60 pairs of inline skates were sold. Divide the skates into 2 equal groups. There are 30 pairs in the upper half and 30 pairs in the lower half. So the 30th and 31st pairs of skates are in the middle. The sizes of the 30th and the 31st pairs of skates are both 8. So the median size is the mean of those 2 middle sizes, which is 8. So you will be looking at 60 numbers, but all I'm saying is kind of use math to your advantage, not just number listing. So look at those in chunks and find which ones would be the 2 middle. Now, why do we have to find the mean of 8 and 8? Why do we even say that we should do that? Well, technically, there's an even number in the set, 60, so we would have to find the average of those 2 in the middle. They're both 8, so it technically was a formality to find the mean of the 2. But if one of them was 7 and one of them was 8, we'd have to find the mean of that to find the median, which would have been 7.5. But here we have an 8 and an 8, so the median is 8. All right, here's the last piece. This will be a question you'll be asked in the future a lot, maybe on your test. Now that you've found the measures of central tendency, which measure of central tendency best describes the data set? And, maybe even more importantly, justify your answer. All right. They say the mean size is 7.7. However, The usual sizes for inline skates are either whole numbers or halves. So like I said earlier, 7.7 doesn't exist. So the mean figure 7.7 may not be a realistic number for describing that data set. The mode and the median are both size 8, which is a realistic number for describing the data set. So the mode and the median may describe the data set best. It may have sounded like a lot of words there, but they backed up their answer. I'm not going to expect a fully correct answer unless it tells me why the measures of central tendency you picked as best representing the data are best representing the data. All right. Let us flip over to page 266. I know this is a longer lesson today, so if you want to pause now and come back to minute 11 of this video tomorrow, you are completely free to do that. So starting at minute 11, we'll be on page 266. All right, welcome to part 2. We are finishing up chapter 14, lesson 0.4. 14.4, last math official lesson of the year. All right, if you're still watching from before, we're still on page 266. And if you're joining it again the next day, 266. We're now relating the measure of center to a skewed distribution. This is actually a lot easier than it sounds. Follow along. The dot plot shows the daily pocket money of a group of students. We don't talk a lot about pocket money, but this will still work. Each dot represents one student. Little guy on the side says, in a skewed distribution, the mean and median are always different. Ooh, think about that. In a skewed distribution, remember we talked about that in our previous chapter with dot plots, so what it means to be skewed. The mean, or the average, and the median, the middle number, are always different. All right, well, let's find the mean of daily pocket money. Mean equals the total amount of pocket money divided by the total number of students. So they have 6 ones, they have 4 twos, they have 3 threes, they have 1 4, 0 5s, and 1 6. So they're gonna add those all up and then divide by the total number of students, which is the total number of dots, so 15. So they're gonna get 33 divided by 15, which when they turn it into decimals, which works well for money, they get $2.20. All right, that is the mean daily pocket money. The average amount is $2.20. Now it says, what is the modal daily pocket money? Well, the greatest number of students, and we can see this super easily with the dot plot. What's the highest stack of dots? The greatest number of students have $1. So the modal daily pocket money is $1. What is the median daily pocket money? Well, there are 15 students altogether. The 8th student's in the middle because it's an odd number, so we know that student number 8 is going to be in the middle. Because there are 7 students to the left, it says, and 7 students to the right. So the median daily pocket money is $2. Now comes the big question. Which measure of central tendency best describes this data set? And justify your answer. The mode is $1, but it only represents 6 of the 15 students. So even though the mode is $1, it doesn't really describe the whole group the best. It says, so the mode does not describe these data well. Yes. The mean is $2.20 and the median is $2. Both of these numbers could be used to describe the set of data. The mean takes into account the students who have even more pocket money. We would call them, remember, outliers if they're kind of off in the distance on our graph. But the median better describes what most students have in pocket money. It's not skewed by that one over to the side that has $6 a day. All right, now step E is the new one. Relate the measures of center, which we say are the measures of central tendency. If they say measures of center or measures of central tendency, don't freak out. That just means mean, median, mode. They say measures of centers, so they don't have to say, relate the mean, median, and mode to the shape of the data distribution. All right, the shape of our little dot graph on page 266. The shape of the distribution is skewed to the right. Remember, we say skewed in the direction of where that little short tail is. Skewed to the right. The mean gives more weight to the values on the right than the median does. That's saying, when we average everything, it's almost like it counts the ones on the right as more per dot because it pulls off our average to closer to that side. So the mean is to the right of the median, which is the true counted middle. All right, let's talk through that one more time before I let you go, because I want you to be able to defend your answers like that. Because this data is skewed, it means that the average is more affected and shifted from the true middle median because we have numbers way off down to the side. If we didn't have the $4 student and the $6 student, all of the measures of central tendency would be clustered around that $1 to $2 amount. But because one kid has $4 and one kid has $6, our data is skewed. Our mean gets kind of pulled off toward a higher amount. So our average amount is $2.20, even though most kids only have $1 or $2. That's what that means. Oh man, math jokes. Okay, so they explained that and then concluded. So the mean is to the right of the median. Something that you're going to be having to do a little more when you get into higher math is explaining yourself more in your reasoning. I know in upper school math, sometimes they have you do math journals where you kind of have to write a paragraph explaining what you just did. You might not get to those for a while, but this is really good practice for that. When we do math, we want to be able to explain what we've done and that we understand it. So thanks for tuning in to this video in 2 parts or either in one long stretch. I hope you enjoyed our last math lesson of the year. Again, forgive my excited jitters and misspeaks. Is that a word? Misspeaks? Misspoken words. But it was just fun to finish up with you all, and I'm so glad we made it to the end of this math book together. All right. Happy homework.